Hello everyone. Now today I am going to explain the particular integral methods. How to find the particular integral methods. There are 5 methods to find the particular integral. Out of the 5 methods, one by one we will go. Before going to start the particular integral methods, first we will see what is inverse operator. 1 by f of d is called inverse operator. 1 by f of d is called inverse operator. We have to find f of d into y is equal to q of x. The finding the particular integral of f of d into y is equal to q of x. To find the particular integral, yp is equal to particular integral is equal to 1 by f of d into q of x. To find the particular integral, we need to use 1 by f of d. 1 by f of d into q of x is that function of x which when operated upon f of d gives x. X means q of x. Now that's why particular integral is equal to always we should write 1 by f of d into q of x. Particular integral we can denote with yp. Yp means p stands for particular integral. Yp is equal to pi is equal to 1 by f of d into q of x. And then the next one is methods to find the particular integral cases. Before going to start the particular integral cases, what is the meaning of 1 by d? 1 by d stands for integration. Whenever 1 by d occurs, you have to integrate. 1 by d stands for integration. Example, 1 by d into cos x, 1 by d into sin x, or 1 by d into x square, 1 by d into whatever, some e to the power of 2x, whatever the term. 1 by d into cos x is equal to, what is the meaning of that? Integral cos x dx, that is equal to minus sin x, depending on the formula. 1 by d into whatever the term occurs, you have to integrate that particular term. Will give you the 1 by d stands for integration, you remember. Now first method 1, to find the particular integral. Method 1, what is the method 1? There are 5 methods are there. Now let the given equation be in the form of f of d into y is equal to q of x, where q of x is in the form of e to the power of ax. When q of x is equal to e to the power of ax, we have to use the method 1. To find the particular integral formula, whenever q of x means RHS part, q of x is in the form of e to the power of ax. The particular integral is 1 by f of d into e to the power of ax. By substituting, simply you will get the answer by substituting d is equal to, wherever d is there, by substituting simply d is equal to a. You will get the answer if f of a is not equal to 0. After substituting d is equal to a, if you get the denominator value is equal to 0, then you have to go to the second formula. If denominator is not equal to 0, some value if you get, then that is the answer. 1 by whatever that, after substituting f of a value, whatever the answer you will get, that value only answer. This formula exists whenever f of a is not equal to 0. You have to simply substitute d is equal to a. If you get a denominator is not equal to 0, then that will become the answer. If the denominator is 0, after substituting d is equal to a, if you get denominator is 0, sometimes after substituting d is equal to a, we are getting the denominator value as 0. At that time what we have to do? We have to differentiate f of d. Whatever f of d is there, that one you have to differentiate, and then after differentiation you substitute d is equal to a. After f dash of a, what is the meaning of f dash of a? You have to differentiate f of d, and then you have to substitute d is equal to a. At that time f dash of a is not equal to 0, then it will become answer. Whenever you differentiate first time, you will get one extra term called x. Whenever you differentiate, the answer will become x into e to the power of ax by f dash of a. F dash of a means we differentiated first time and substituting d is equal to a. Whenever you differentiate first time, you will get one x term, x into e to the power of ax. For suppose after substituting After differentiating first time, after substituting d is equal to a, f dash of a is equal to 0 if you get, f dash of a also 0 if you get, you need to differentiate second time, and then second time you differentiate and substitute d is equal to a. Whenever you do the differentiation second time, x square into e to the power of ax, you will get x square into e to the power of ax. You will get, that's why f dash of a is not equal to 0. In the same way, if you differentiate third time, for example, f dash of a is, f double dash of a is also 0 if you get. If you get f double dash of a also, if you get 0, then you have to write triple dash of a. If f double dash of a is not equal to 0, is equal to 0. F triple dash is not equal to 0. A is not equal to 0. This is the x cube. Like this, you will get the formulas. Now, whenever after substituting second time, f double dash of a is not equal to 0, then x square you will get. F triple dash also in the same way you will get. These three are the formulas. Now, we will do the first problem. Now, we will see the first problem. Solve d cube y by dx cube minus 3d square y by dx square plus 4y is equal to e to the power of ax. Using the LHS part, we need to find the complementary function. Using the RHS part, we need to find the particular integral. Therefore, the complete solution will become CF plus PI. Complementary function plus particular integral will become the complete solution. Now, first we will write the given equation in the operator form, d cube minus 3d square plus 4 into y. This is the cubic equation. You will get 3 roots. Using any of the method, using calculator or any of the method, find the 3 roots of this equation. Minus 1, 2, 2 are the 3 roots. Minus 1 is the distinct root. That's why c1 e to the power of minus x. And 2, 2 are the repeated roots. That's why c2 plus c3x into e to the power of 2x. This is the complementary function. yc is equal to, like this we need to find the complementary function. yp. Now we will find the yp. Now RHS part, why I am applying first method only, why not second method or third method like that? Now RHS, if you observe the RHS is in the form of e to the power of ax. Whenever RHS is in the form of e to the power of ax, apply the first method. Now yp is equal to the formula, inverse operator. Yp is equal to 1 by f of d into q of x. 1 by f of d, d cube minus 3d square plus 4 into e to the power of 3x. 1 by f of d. What is our f of d? D cube minus 3d square plus 4 into e to the power of 3x. Substitute d is equal to a. A means e to the power of 3x means a is equal to 3. How much you will get? 1 by 3 whole cube minus 3 into 3 square plus 4. And if you simplify, how much we will get? The value is equal to 4. You will get 1 by 4 into e to the power of 3x. That means after substituting d is equal to 3, we have got some number either positive or negative. Then what is the meaning of that? This is the answer yp. Whenever you get a 0 answer, then we have to think about therefore the complete solution y is equal to yc plus yp. Yc is c1 e to the power of minus x plus a c2 plus a c3x into e to the power of 2x plus yp is 1 by 4 into e to the power of 3x. This is the answer. Whenever denominator is not equal to 0, then that will become the answer. The next question, if you see the next question, d cube plus 3d square plus 3d plus 1 into y is equal to e to the power of minus x. Now for this equation, auxiliary equation, by substituting d is equal to m, you will get the auxiliary equation m cube plus 3m square plus 3m plus 1 is equal to 0. If you find the roots, you will get minus 1, minus 1, minus 1. Therefore, a complementary function yc is equal to the complementary function yc. If the 3 roots are equal, what is the formula? c1 plus c2x plus c3x square into e to the power of minus x is the formula. If the 3 roots are equal, then the particular integral yp is equal to 1 by f of d into q of x. What is q of x? RHS part is the q of x. 1 by f of d into q of x. 1 by, what is our f of d? D cube plus 3d square plus 3d plus 1 into, what is our q of x? E to the power of minus x. By substituting d is equal to minus 1. How much we will get? We will see. By substituting d is equal to minus 1 whole cube is minus 1 plus 3 plus 3d minus 3 plus 1 minus 1 plus 3 minus 3 get cancelled, e to the power of minus x. Therefore denominator we have got 0. Whenever you get the denominator 0, then what we have to do, we have to differentiate first time. 3d square, if you differentiate this denominator, 3d square, 3 2s are 6d plus 3 into e to the power of minus x. Again substitute d is equal to minus 1. Whenever if you differentiate x into e to the power of minus x, I have differentiated first time, that's why x into e to the power of minus x by, now I am substituting d is equal to minus 1 here. Minus 1, 3 minus 6 plus 3. Again we are getting 0. So again I am differentiating second time. 3 2s are 6d plus 6. Whenever you do second time differentiation, you will get x square into e to the power of minus x. Substitute d is equal to again minus 1. Now if you substitute d is equal to minus 1, how much you will get? Minus 1 if you substitute here, minus 6 plus 6. Again we are getting 0. Whenever you get third time you differentiate. I am differentiating third time. X cube into e to the power of minus x. If you differentiate third time, 6d plus 6, you will get 6. If you get 6, you cannot substitute anything here. There is no d. That's why substitute that e to the x cube into e to the power of minus x by 6 is the yp. Because there is nothing is d. If is there any d, you can substitute d is equal to minus 1. This is yp. Therefore, y is equal to yc plus yp. Yc value plus yp value you have to write. The next question is d cube plus 1 into y. d cube plus 1 into y is equal to e to the power of x plus 1 whole square. Whenever e to the power of x plus 1 whole square is there, you expand the whole square. E to the power of 2x plus a plus b whole square. A square plus 2ab plus b square. E to the power of 2x plus 2 into e to the power of x plus 1. Auxiliary equation is m cube plus 1 is equal to 0. The roots you will get complex roots. M is equal to minus 1 and 1 plus or minus I root 3 by 2 you will get. Based on the 3 roots, we will get the complementary function. This is distinct root first formula, and complex roots, the e to the power of ax into c cos bx plus sin bx, like that we wrote the formula yc, and yp is equal to 1 by f of d into q of x. 1 by, what is our f of d? dq plus 1 into e to the power of, what is our RHS? e to the power of 2x, e to the power of 2x plus 2 e to the power of x plus 1. Whenever 3 terms occurs, whenever 2 terms or 3 terms, if only 1 term we can write 1 term. If any 3 terms or 4 terms like that occurs, what you have to do? Split into 3 parts. 1 by dq plus 1 into e to the power of 2x, 2 into constant write down outside, 1 by dq plus 1 into e to the power of x plus 1. 1 is nothing but e to the power of 0x. Whenever constant occurs, you have to write e to the power of 0x. 1 by dq plus 1 into e to the power of 0x. Substitute d is equal to 2. Substitute d is equal to 1. Substitute d is equal to 0. 3 different problems. That is equal to 1 by d cube is 2 cube is 8 plus 1 into e to the power of 2x plus 2 into d cube 1 plus 1 into e to the power of x plus 0 plus 1 into e to the power of 0x. 1 by 9 into e to the power of 2x. 2 to cancel. 2 by 2 into e to the power of x plus 1 into the power of 0x is 0 1 only. That means 1 by 9 into e to the power of 2x plus e to the power of x plus 1. This is the yp. Therefore, y is equal to yc plus yp. What is our yc? Our yc, big yc is there. That yc plus yp value if you write, that is the answer. Thank you.